Just going to look at a couple other formulas that can come in handy when we're doing our coordinate geometry problems. The first one's perpendicular distance. Anytime they ask you to find a distance from a point to a line, they're talking about the shortest distance, which is the perpendicular distance. There's our point, x1, y1, and we want to find how far away it is from this line. The equation of the line needs to be in general form for this. So we have it in general form, and that's the distance we're looking for. So the formula ends up being this. Basically on the top of the fraction you've got the equation of the line. We make it absolute value because we're talking about distance and we want a positive number. But we substitute into the equation our point, x1, y1. The bottom of the fraction is essentially Pythagoras' theorem. So the square root of a squared plus b squared using the coefficients of x and y. Because it's essentially derived from that. You can create a right angled triangle here and it works it all out. So alright, let's do an example. We're going to find the equation of the circle. The tangent is this line and we know the centre of the circle is 1, 4. What's its radius? So here's our circle. I mean, I haven't actually put it on the number plane, but the centre is 1, 4 and our tangent would touch it somewhere and we want to find the radius. Now this of course requires us to remember some circle geometry, that the radius is always perpendicular to the tangent at the point of contact. So essentially we've got to find the perpendicular distance of the point to that line. So okay, top of the fraction goes the equation of the line, but I've substituted in the x and the y value of the centre. And then the bottom of the fraction, there's our Pythagoras' theorem, but using the coefficients of the x and the y. And we end up with 25 on root 25, which cancels quite nicely, 5 units. So now I know the centre of the circle and I know the radius of the circle. So therefore the equation of the circle must be x minus 1 squared plus y minus 4 squared is 25 because we've shifted our circle centre and we know the radius is 5. So that's our perpendicular distance formula. Just a side note to that. Why is it absolute value? Because when you've got the line, on one side of the line, it's always going to have a positive result when you substitute the point in. And on the other side of the line, it's always going to have a negative result. So if that's our line here, what I'm saying is, on one side would be the region, if we were to shade the region in, we'd get the region of ax plus by plus c is greater than 0. So every point there, when you substitute it in, would give a positive number. On the other side would be the region where it's less than 0. I suppose it's a way of telling whether points are on the same side of the line or on the opposite side of the line, because you could substitute it in and if they come up with the same sign, we know they're on the same side. But if one came up with a negative number and one came up with a positive number, we'd know they're on different sides of the line. Now, is that useful? Maybe not, but I mean, it's something we could use if it ever does crop up. The other sort of question is this specific one. If we want to find the equation of a line which goes through a particular point but also the point of intersection of another two lines. This is one of these ones where there's a long way of doing it and there's a quick way of doing it. And we'll look at both. So here's our question. We're going to find the equation of a line passes through the point of intersection of these two lines, but it also goes through the point 1, 2. Well, if we want to find the equation of the line, we need a point and we need a slope. We've got a point, but we've got no idea about the slope at this stage. I need another point to work out what the slope's going to be. Well, that other point is the point of intersection. So how do we find the point of intersection? We solve the two equations simultaneously. That's the first thing I need to do. So let's make it look like simultaneous equations. So that's how we're used to sort of seeing it. Now, simultaneous equations, we want to make the coefficient the same. I've already done that, you'll notice, in the first one. I multiplied everything by 5, and we've got the coefficients of y now the same. So we subtract, and I've got 7x is negative 14. So okay, we know x is negative 2. I can substitute into any of those equations to work out y, and I get y is 3. So we now have our second point. Okay, still work to do. Now we want to find the slope of the line. So it's the slope between these 2 points. Okay, put it in our slope formula. Remember, the order is important. I've used which point? I've used the point negative 2, 3 as the first point. So I've got 3 minus 2 over negative 2 minus 1. We now have a slope of negative 1/3. Okay, we're finally there. We've got a point. We've got a slope. Let's put it in the point slope formula. Get rid of that fraction. There it is in general form. I've got the equation of the line. X plus 3y minus 7 equals 0. That's the long way. And that was a lot of work. We had to solve simultaneous equations. We had to find a slope. Then we used the point slope formula. There is another way. There's the equation of the line. Well, I've generalised it for anything. But why will this work? The point of intersection is one of the points that this line's going through. So the point of intersection must lie on this line. Now if it lies on this line and it's the point of intersection, then when I substitute it into the first line, I get the answer 0. So I know that's true. But it also lies on this second line. So when I substitute it into the second line, I also get 0. So it actually doesn't matter what this k is, I'm always going to get the answer 0. Now that is an equation of a line, because I've got something x, in this case it's a1 plus k lots of a2. I've got something y, b1 plus k lots of b2, and then I've got a constant number. So it is an equation of a line. I just need to work out the correct k, but I have another piece of information. It also goes through another point. I can substitute that in and work out k. So let's use that idea for our question. We had 2 equations of the line. It does not matter which one we multiply by k. We can choose. In fact, you could theoretically multiply both by a constant, but why make the question harder for yourself? We just do it with one, it's going to be easier. So I've multiplied the 3x plus 5y minus 9 by a constant number. That's the equation of my line. I just need to work out what k is. But I know that the point 1, 2 lies on that line. So when I substitute it in, I should get the answer 0. Bit of expanding algebra. We end up with 5 plus 4k is 0. K is minus 5 on 4. Right, I now have the equation of my line. Of course, we're not used to seeing lines written like that, so let's tidy it up. Get rid of the fraction, multiply everything by 4, tidy it up, bring like terms together. 7 goes into everything there, and we end up with the same line. X plus 3y minus 7 equals 0. So the quicker way of doing it is saying, well, I know the pattern. I know it's going to be something x, something y, and a constant number. So I know that pattern. I just got to work out the correct k that will find the exact line that I'm talking about. Again, quicker than doing it the other way, where there was a lot of work to do. Okay, so that'll do us for coordinate geometry 7E. Handful of questions there. I've also in the sheets attached some past HSC questions which came from the old course.